Yeah, g'day and welcome back. My current project is to modernise this beautiful Schaublin 125 CNC lathe. So this week I needed to make a few parts, but as usual, more than half is scrap because I used the wrong material. Well, this week, this is what I'm working on. I think I mentioned in one of my earlier videos that these are my 24 volt output pins to control various different systems. Unfortunately, I've only got 8 of them and I've used them all, but I still have some more systems that need activation. Luckily, I've got some 5 volt output pins still free. So to control 24 volt systems with 5 volts, I'm going to add a relay board. So it'll take 5 volt control in and I can run the 24 volts through the relays. The question is, where do I put it? I'm kind of stuck for space, so I've decided I'll just mount it above this board. This is called the Mesa 7i92. It's kind of the brain that controls all of the other boards. It won't have any other connections, it's just got power, Ethernet, and a connection down into this one. So I'll just pick up its 4 mounting screws, make an adapter plate, and mount this above it. I've had a few people lately say that they really like my channel, and they're surprised that it doesn't get more traction. Well, if you feel that way and you'd like to help the channel, one way that really helps is send a link to somebody else who might like this, or put a link to one of my videos in one of the forums that you hang out in. I'd appreciate it. Right, relay board mount. Add 1 hole. Make a pattern of the holes, make a second hole, make a pattern with the second hole, relieve the area below the board, chop out the middle, and then fill up the corners. And then all you need to do is export it as an STL file. Open it in Cura, slice it, check it, and send it to the printer. When I have the macro set up to do those stop motion videos, I seem to get quite a lot of stringing. Always stopped in this spot, made a mess of it. Tried printing another one. Well, got about halfway through and it was looking pretty good, but then it also failed. The second one failed because the nozzle got clogged. It was doing nicely until then, and I had to end up printing it a third time. But the third one looks like a nice print, so I'll use that. I also took the advice of Phil and printed the spaces this time, rather than turning them. Mail time. This vise came up on one of the German forums for a really good price. It's new, but it's obviously got a bit of surface rust. That doesn't bother me. It's even got a big warning label on it. I don't really need it, but I've heard good things about the repeatability of this style of jeweler's vise, so I figured I'd give it a try. This hole over the back of the control cabinet, that's going to be my main disconnect point. It's 6 centimeters in diameter. It's going to need a blanking plate, which carries 5-pin connector for the pneumatic air supply module. It's going to need the main 3-phase power in, and it's going to need a couple of pneumatic couplings. So this one's just a mock-up. Okay, I can see now that's not going to work. I need space for both sides. Yeah, that's going to have interference between those two, and interference here. It looks like I can't get all 4 connectors onto one plate, but luckily further up here on the back, there's this M24 threaded hole, which is one of the main lifting holes. So if I print up an M24 to M20 adapter, it means I can move my main power cable away. Kind of like this one, I guess. Then I'll have space for the other 3 on one plate. Did you guys see that the space launch system is supposed to launch tomorrow, which is the 16th of November? Let's hope it finally goes up this time. They got pretty lucky that that last hurricane that went through didn't topple the thing over. Quite a risk leaving a rocket like that out on the launch pad when I think, what was it, a Cat 1 hurricane came through. I've done a fair bit of wiring in the last couple of weeks, but it wasn't really graphical, so I didn't take any video of it. But once I've got all this assembled, I can test my air supply module. So let's see if we can control this from Linux CNC. On. Okay, that's working. Okay, I can hear that I've got a bit of a leak there. Okay, it's the air filter drains leaking. Now I've got the main air supply solenoid under control. Let's see whether the pressure switch is working. So my grey and white wires are the pressure switch. Let's test that. Oh good, air on. So now we're going to wait till the pressure to drop here. And air off again, switch goes off. Cool, it looks like that switch is working. Oh look, it's our number one fan, Nico. So yeah, what do you think? These are the disconnect parts I made.
Still looks ugly to me. It doesn't look very nice. But it's still just a prototyping.
No, that's the finished one. I'm going to install that.
Well, that was not a question. Did you terminate a new machinist channel?
I know it's a machinist channel, but I mean, this is...
Not a machinist job.
It's good enough, right?
It could be temporary, the final solution. I would recommend, however, just take some efforts, take the time, and make a nice video and let us enjoy that.
You mean print another plastic one?
No, don't change the color. Just go for machine this part. It's an easy job. You just take the aluminum bits, put it in the Maho, do some magic, and that's it.
Aluminium magic in the Maho?
That's a 2 hours job, top.
Yeah, right. What about you guys? Do you agree with our number one fan? I guess I don't even need to ask, do I? First I need to touch off on the part, find the center, then I need to set up each of my tools, and then we can start machining. Okay, well that completes the first operation on the first one. So now I'm going to turn it over, clamp the other side, and repeat. Well, that's as much as I'm going to do on the mill. I'll do the rest on the lathe. Back gear for slow speed, for parting. Now I'm not going to be able to part this right off, but I'll just put a bit of a mark in it so that I can align my bandsaw better. Oh, I can use my new vise to hold it while I'm cutting. Well done. About here I should have put more effort into bumping this to make it run round. I only put in pilot holes with a CNC. I'll clearance them now. This backing plate, these holes need to be threaded M4, so tapping drill size. Now this might be famous last words, but I'm pretty comfortable tapping M4 in aluminium with the hand drill. I guess it's a trade-off. You don't have the feel like you'd have with by hand. The torque is nice and constant, and you don't have the side forces that you might put on with your hands. So. For M3 I don't have a machine tap, so I have to do it with a bunch of hand taps. I guess I can now rip this apart and switch over the components. Might have made those holes just a little bit too tight, but this is stainless steel, so I can probably just thread it in. Probably should have made it maybe 1/10 or 2/10 of a millimeter larger. The second one just took a lick with a file to take a burr off, and it goes together easily. I think Nico was right. I like the machined one better. Right, let's install that. So NASA did launch SLS successfully. Cool. Seems like the mission's going really well. The most powerful rocket in like the last 50 years. Probably the most expensive rocket ever. I guess if Elon Musk stops dicking around with Twitter and actually launches his like super heavy rocket, that's probably going to be the end of SLS. Kind of a scary concept that they're only going to do one practice run and then go straight to a launch with crew. But hey, I guess they know what they're doing. Sure hope so. Okay, with that done, I can now thread through the main power cable. Well, that's it for this week. I'll catch you next time.